Hello, good evening students. How are you all? Okay, so till now in surface area and volume, we have covered the surface area of and volume of the combination of the figures like square, cube, cuboid, cylinder and sphere and hemisphere and the combination of them also, right? So today we will learn about the new one, which is the frustum of the cone. We will learn about the surface, how to find the surface area of the frustum and how we can figure out the volume of that frustum. But before starting that one, there are 2-3 questions which we were left in the last class. So let us start with those questions based on the same concept of combination of the cylinder and cuboid. So let us start with the question. So the question says, and all of you try this. Water in canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes This is the question. So it says it says water in canal, the dimensions of the canal are given, 6 meter wide and 1.5 meter deep, is flowing with a speed of 10 km per hour. This is the speed of the water that is flowing through the canal. We have to figure out how much area will it irrigate, in 30 minutes if 8 centimeter of standing water is needed. So the question, there is a canal and from that canal the water is coming out and it is going in the field, and the dimensions of the field are in the shape of a cuboid, because when it will irrigate a field, some area will be there and then the height of that water will be there. So we have to figure out how much water will be there or how much area will be there in the field which the water will be occupying in 30 minutes. The concept you have to use over here is that whatever amount of volume is coming out from the pipe, same amount of volume is going in the field. So first of all, try this one, all of you, then we'll discuss this. Hello Shillong Center, how are you? Shillong Center, are you getting this question? Both of you. Are you getting this, like how to solve this question? Good afternoon, Tamenglong Center. Try this question based on the concept of volume. Good afternoon, Sisipur. Shillong, are you getting it? Shillong Center? Little problem this one. Okay, let me explain you this question. It's a different one. Basically, it says there is a canal. So canal is in the shape of a cuboid, 6 meter wide and 1.5 meter deep. So you can understand like this. So this is the canal. These are the dimension of the canal. The dimension of the canal means the cross-sectional view, the facing. So it is like this. This is 6 meter and the height is 1.5 meter. And water is coming out of this canal like this. Water is coming from this cross-section. So the shape in which the water is coming out, that is in the shape of a rectangle, and the dimension of the rectangle is this one. And here is the pond in which the water is getting collected, or you can say the field. The question is like this. This is the pond in which the water is getting collected. Now, it says that how much area it will irrigate in 30 minutes if 8 centimeter of standing water is required. 8 centimeter means this height. In the field, height of water should be 8 centimeter, that is required. Now, we have to use only one concept, that the volume coming out from the pipe should be equal to the volume which is there in the field. Now, the concept we will use over here is that volume is given by area of base multiplied by the height. That is the general formula for the volume of any prism. Like here, if we have the cuboid, the volume of cuboid is what? L into B into H. This is the volume for the cuboid. In this, L into B, that is nothing but the area of the base, and multiplied by the height. Similarly, if we have the volume of the cylinder, we have pi r square h as the volume of the cylinder, and you know in the cylinder the base is of circle. So this pi r square is nothing but the area of the circle multiplied by the height. So volume is basically area of the base multiplied by the height. So here we have to figure out, since we have to figure out how much area it will irrigate, so volume of this tank in which the water is getting collected, that will be area of base multiplied by height. So we have to equate all of them. So we will do volume of water from canal is equal to volume in field. Now the volume in the field, that will be nothing but the area of the base and multiply by the height, how much height will be there of the water, and height is given, which is 8 centimeter. So area of base multiply by 8 centimeter, that is the volume of the water in the field. Now we have to equate it to the volume of the water coming from the canal. Again, if you see from the canal, the area of base, that is the area of this rectangle, and height will be like how much water is coming out in 1 minute. The speed of water is given 10 km per hour. Now what do we mean by this 10 km per hour? It means that in 1 hour, the length, or you can say the height, in which the water will be flowing, the length of water will be 10 kilometer. Or to get a better understanding, it means like if this is the face of the canal, so in 1 hour this much of the water will be there, or you can say this length will be 10 kilometer in 1 hour. So if we multiply the area of this face, nothing but the area of the base multiplied by the length of the water which is coming, that will get the total volume. Now here we have to take special attention in the units. As you can see in the question, like on the right hand side, this is 8 centimeter, the speed is given in kilometer per hour, and the dimension for the canal are in meter, and the time is in minutes. So we have to take care of the units while solving these questions. So volume of water, so in 30 minutes, so we can say in 60 minutes, the length of water is 10 kilometer, and 10 kilometer we can write as 10,000 meter, because in 1 hour the length is 10 kilometer. So in 1 hour is basically 60 minutes. So in 60 minutes the length of water is 10,000 meter. And since we have to find how much area will be in 30 minutes, so in 30 minutes length of water is just half of this one, which is 5,000 meter. So in 30 minutes the length of the water is 5,000 meter. So now you can figure out the volume of the water coming out from the canal. So volume from canal, that is equal to area of base. Area of base means the area of that cross section, which is 6 meter into 1.5 meter into the height. In 30 minutes the length of the water which is coming out of the canal is 5,000 meter. So that is 5,000. This is the volume of the water from canal, and how much volume it will be there in the field having the height of 8 centimeter. So volume will be area of base multiplied by 8 centimeter. So we have to equate it to that. So 6 into 1.5 into 5,000, that is meter cube, is equal to area. Now it is 8 centimeter, so we can convert that centimeter into meter also. 8 centimeter is nothing but 0.08 meter, divide by 100. So now you can see we have converted all of them into the same unit, which is in meter. Now you can cancel out this meter from both the sides. This meter and this meter will get cancelled out. So you can see the left hand side, the unit is only meter square, which is the unit of the area. So you can say area will be equal to 6 into 1.5 into 5000 divided by 0.08. That will be the answer. Now you can simplify this one. That will be 100. If you remove this decimal, that will be 10. So now you can cancel out this one. So 2 3 times and 2 4 times. And this will be 2 2500. So it will be 45 into 5, 225 into 2500 meters square. You can simplify this one, and that will be the final answer for the area of field. Are you getting it, all of you? Any doubt in this question? Only what we have done, we have just equated the volume coming out from the canal to the volume of the water in the field. Any doubt? Presidency, Shillong, Sisipur, Tamenglong, Tetso. Rest of the centers? Okay, repeat. See, this was the question. Question was, there is a canal, and that canal is 6 meter wide and 1.5 meter deep. So basically, these are the dimension of the face of the canal. So you can see the face of the canal is in the shape of a rectangle, having the dimensions are 6 and 1.5. Water is flowing from it with a speed of 10 km per hour. It means, yes, Shillong, the answer is right. So water is flowing with a speed of 10 km per hour. It means in 1 hour, the length of the water coming out of the canal is 10 km. We have to figure out how much area it will irrigate in 30 minutes if 8 centimeter of standing water is needed. In that area, 8 centimeter of water is needed. So only thing you have to take care of is that the volume coming out from the canal, that is equal to the volume in the field. Now volume is nothing but given by the area of base multiplied by the height. So since canal is in the shape, the face of the canal through which the water is coming, it is in the shape of rectangle, having the area of cross section like this, and water is coming from this. So we have to figure out how much volume is coming out of the canal. So first we will figure out the area of the base, which is 6 into 1.5. Now the speed of water through which it is coming from the canal is 10 km per hour. Or you can say in 1 hour the length is 10 km. So in 30 minutes how much water will be there? So you can see this in 1 hour is nothing but 60 minutes. So in 60 minutes length of the water is 10,000 meter. So in 30 minutes it will be 5,000 meter. So the length of the water which is coming out of the canal in 30 minutes is 5,000 meter. So we can figure out the area of the volume of the canal is length into breadth into height. That is the volume of the canal. Now the same volume will be of the water in the field. And in the field it is already given that in the field the height of water should be 8 centimeter. So volume will be area of base multiplied by 8. So we have equated to that also. Area of field multiply the height 8 centimeter. Make sure to convert all of them into the same unit. So I have converted all the things into meter. So I have converted this 8 centimeter also to 0.08 meter and then equated both of them, and on solving we will get the area is this one. So the final answer for this one would be 562,500 meters square. This much of the area irrigated by the canal in 30 minutes. Getting it, Presidency? Any doubt now? Any doubt in this question? Okay, you want me to, this government higher secondary school, Itanagar. So in which, like you want me to explain it from the starting, or there is some doubt in any of the step? Okay, from the starting. Okay, now pay special attention. The question says that there is a canal through which the water is coming at a speed of 10 km per hour. The dimension of the canal is given 6 meter wide and 1.5 meter deep. So this is the canal. The dimension of the face of the canal is rectangular by looking at the dimensions 6 meter wide and 1.5 meter deep. So the water is coming through this shape. Now we have to figure out how much area it will irrigate in 30 minutes if 8 centimeter of standing water is required. Now you can see that only thing you have to take care of is that the volume of water coming out of the canal, that will be equal to the volume of water in the field. Now the field is in the shape of a cuboid because since we have to figure out the area it will irrigate and we require 8 centimeter of standing water in the field. So basically the height of the water is given in the field, we just have to figure out the area of base. So volume in the field will be area of base multiplied by the height. So we have to figure out this area of base. So what we will do, we will figure out what is the volume of the water coming out of the canal. So now in the canal, volume will be again the area of base multiplied by the height. So area of base is nothing but 6 into 1.5 meter. That is the area of the base of the canal. Now how much height or how much length the water will have in those 30 minutes. So what do we mean by the speed? It says the speed of water through which it is coming from the canal is 10 km per hour. It means in 1 hour, the length of the water will be 10 km. It means in 1 hour में 10 km की length आएगी. So basically in 60 minutes, length will be 10,000 meter since 1 kilometer has 1000 meter. So in 30 minutes, it will be 5,000 meter. 30 minutes mean half. In half, it will be 5,000. So in 30 minutes, the length of the water will be 5,000 meter. So we can multiply the area of base of the canal with this 5,000. That will give you the total volume of the water. So this is the volume of the water, 6 into 1.5 into 5,000 meter. And this volume of water will be equal to the volume of the water in the field. So volume of water in the field will be area of the base of the field multiplied by the height of the field, which is already given 8 centimeter. And I have converted that 8 centimeter also to 0.08 meter. So now we just have to equate both of them, and on solving this one, we will get the area as this. This question is basically based on the concept of the volume conservation. Volume of water from the canal is equal to the volume of the field. Now let us do one more question of the same type, then it will clear your concepts more. Itanagar, is this your first class? Okay, because I think since this is your first class, okay, second time. So maths class is the first class, I guess. So that's why you are facing problem. We are on the end of this chapter. This is not, this is chapters of surface area and volume. That's why you are having difficulty, I understand. And we are on the last part of the chapter. Today we are about to finish this chapter. So maybe you can watch the previous videos first, then you will be able to better understand this chapter. Because we have done 3-4 classes previously also. Right, because I understand, like if you are attending the first time, then it is difficult for you to understand the concept because you have not understood the previous one. So I request you to go through the, this is surface area and volume, chapter 13. Surface area and volume. So that's why go through the, yeah, but first go through the previous videos, and if still you are having any doubt, then you can ask me. And you can WhatsApp your doubt to me also. Okay. So all of you, this question based on the same type, it says there is a pipe having diameter of 20 centimeter, cylinder having diameter of 10 meter and height of 2 meter. Water coming through pipe at a speed of 3 km per hour. In how much time will it fill the cylindrical tank? So right now there is a pipe. Earlier in the previous question there was a canal in the shape of a rectangular shape face, but this time there is a pipe and the water is coming through the pipe at a speed of 3 km per hour, and that water is going into the cylindrical tank. The dimension of the tank is also given. So right now you have to figure out in how much time it will fill the cylindrical tank. So again you have to equate the volume of both the things. Volume water coming out from the pipe is equal to the volume of the water in the tank. Try it and take care of the units, because meter, centimeter, kilometer per hour, all of them is involved. ओके सो ईटानगर ये ऐसा क्वेश्चन है कि लाइक इट इज गिवन कि एक पाइप है, तो पाइप का डायमीटर है, उस डायमीटर और एक टैंक है, सिलेंड्रिकल टैंक है, तो पाइप में से पानी आ रहा है और वो सिलेंड्रिकल टैंक को फिल करना है। सो पानी की जो स्पीड है दैट इज, जो पाइप से पानी आ रहा है उसकी स्पीड दे रखी है दैट इज 3 किलोमीटर पर आवर। 1 घंटे में 3 किलोमीटर पानी उसमें से आ रहा है और वो पानी सीधा का सीधा टैंक को फिल कर रहा है। तो आपको ये बताना है कि कितने टाइम में वो जो पाइप है उस टैंक को फिल कर देगा। तो आपको कॉन्सेप्ट क्या यूज करना है इसमें कि जितना पानी पाइप से बाहर आ रहा है सेम अमाउंट ऑफ वाटर टैंक के अंदर जा रहा है। गेटिंग इट नाउ? समझ में आ रहा है ईटानगर? So how many students are there, Itanagar, in your class? Okay, 7. My name is Ankit Khandelwal. Yeah, please start. Sisipur, what is your answer? $15. No. 15 is what? Like minute, second, hour, what? No, 15 hour is not the correct answer. There is no exact formula. Formula is like volume of the cylinder and the volume of the cylinder. That is, the volume of the cylinder is, because both are, pipe is also cylinder and the tank is also cylinder, volume of cylinder is pi r square h. This formula you can use it another. Sisipur, ye answer, this is not the right one. Shillong, what's your answer? Are you getting it? You have to take special care of the units while solving this. $20 EC4. No. Okay, I am solving this one. Please concentrate. The question says there is a pipe. So if you draw the diagram, it will be like this. So this is the pipe, and diameter of the pipe is 20 centimeter. If diameter is 20 centimeter, radius is 10 centimeter, and let us say we are converting all of them into meter. So 10 centimeter means 0.1 meter, right? So this is the radius of the pipe. Now from this pipe, the water is coming in this shape. The water is coming through it, and it is going in a tank. So this is the tank over here, like this. Cylindrical tank is there. Dimension of the tank is also given. Diameter is 10 meter. If diameter is 10, so radius is 5, and the height is 2. So these are the dimension of the tank is also given. Now we have to figure out how much time it will take to fill this tank. So volume of the tank should be equal to the volume of water coming out of the pipe. Now what is the volume coming out of the pipe? So volume from pipe is equal to area of base. So right now the area of base, the base is in the shape of this circle. So whatever is the area of circle, that is the area of base multiplied by the height. So area of circle, radius is 0.1 meter. So area of circle is pi r square multiplied by the height. Now what do we mean by the height? Height means basically the speed through which the water is coming. The speed of water is given 3 km per hour. It means in 1 hour, the water coming, the length of the water is 3 km or 3000 meter. So let us solve this water speed over here. In 60 minutes, the length is 3000 meter. So in 1 minute, the length is 50 meter, right? So since we have figured out this much, so let us say it takes t minutes to fill that tank. So in t minute, length is 50 t meter. Since we have to figure out how much time it will take, so let us say the water is coming from the pipe for t minutes. So in 1 minute, it is 50 meter. So in t minute, it is 50 t meter. So if you multiply this by 50 t, that is the total volume of the pipe coming, volume of the pipe, water from the pipe, and this is in meter cube. Now volume of Now volume of cylinder in which the cylindrical tank, again it is pi r square h. So pi, radius is 5, so 5 square, and height is 2. We just have to equate both of them, and then we have to calculate the value for t. No, Itanagar, this is not the right answer. So now you can equate both of them. So pi 0.1 square into 50t, that is equal to pi 25 into 2. So this pi and pi will get cancelled out. This 25 into 250 and this 50 will get cancelled out. So 0.1 square is 0.01 t, that is equal to 1. So t is equal to 100. So answer is 100 minutes. So it will take 100 minutes, or you can say 1 hour 40 minutes. No, Itanagar, this is not the correct answer, and please don't do like this what you are doing. So the time is 100 minutes. So it will take 100 minutes to fill the tank. Sisipur, is this clear? And Senapati, Presidency, Shillong, Tetso, Itanagar. Is this clear to all of you? Yeah, since you are doing for the first time, that's why you are getting a little bit confused, Itanagar. Sisipur, is this clear? Okay. So let us move on to the next section, which is the last section for this one. And note down the heading. The frustum. So we have to figure out the surface area and volume for this frustum. Now first of all, let us understand what do we mean by name of the chapter is surface area and volume. Okay. So it is frustum. So let us understand first of all what do we mean by frustum. Frustum is basically represented in pyramids. Now the pyramid, all of you know what is a pyramid, in which there is a polygon on the base and the vertex, there is a vertex on the top. Like the polygon can be of like this, a triangular shape can be there, and on the top there has to be a vertex, so it will be like this. Or the best example is the pyramids of the Giza or the Egypt. You have seen those pyramids, how they look like. A polygon on the base and the vertex on the top, and joined by the triangular faces. Like it can be like this, quadrilateral on the base or square on the base, and all the four vertices like this. This can be a pyramid based on the circle, or you can say cone is a special case of the pyramid in which the circle is base. So all these are called pyramid. So now in that pyramid, if that pyramid is cut by a plane parallel to the base, uske base ke parallel agar ek plane se cut karenge, we will get another surface. So like if we cut down, like from the half, if we will cut down this one, if we cut down this one, if we cut down this one. So from the base, parallel to the base, if we cut that pyramid and remove the top portion, whatever is left, that is called the frustum. Or you can understand like this. Let us take a cone. So a cone is like this. a circle on the base, and this is the cone. Now, if we cut it parallel to the base, like from here we have make a cut, and if we remove the top part, so if you remove the top part, it will be like this smaller cone, but what we will left in the bottom, it will be like this. So this shape which we are left in the bottom, that is called the frustum. The lower part of the pyramid, when the upper part is removed, the lower part is called the frustum. This is the shape of the frustum. So now in your chapter, in our syllabus, the definition of the frustum is like when a pyramid is cut by a plane parallel to the base, the lower part of the pyramid is called the frustum. The remaining part of the lower is called the frustum. So like this is the frustum. So in our syllabus, only we have to study about the frustum of cones. So only point is there, the frustum of cone is there. So we have to study about the surface area, volume of that frustum. Now, the thing is that if you look in your practical world, which shape you can see is in the shape of a frustum? Can you give me any examples in which the practical thing you can see, you can tell that this is the frustum of the cone? Bucket, the best example is bucket, right? And the glass of water also. The glass of water is like this. Or bucket, you can say the larger version of the glass of water. So this is the glass of water. So this is the shape of a frustum. Like you can see, the conical part was in the bottom like this. If we join that conical part, that will become again cone. But since we have removed this part, so this is called the plates in which dog eat. A plate in which, that type of plate also you can say this is in the frustum. Well, do you think well is in the frustum? Like I guess well is in the vertical one. Nuclear power plant, vase, vase can be the frustum. So there are so many things which looks like the frustum of the cone. Okay, that's correct. So now we have to study about the surface area and volume of that one. So if you relate it, like in cone, this was the cone having a circle on the base. So this was the radius, and this was the height, and this was the slant height, L. The relationship between those is that L square is equal to H square plus R square for the cone. Now this time, since we have the frustum, it will be like this, right? So you can see there are two faces. On the top also there is a circle, on the bottom also there is a circle, but the bottom circle is larger, or you can say the radius of the bottom circle is larger than the radius of the top circle. So this is the radius of the smaller circle, and this is the radius of the larger circle. You can say this one is R1, and you can say this one is R2. The height, if you join the center to center, that is again the height of the frustum, and this one is called the slant height, which is at a slant position, that is called the slant height. Volcano is in the frustum. Actually, Itanagar, the thing is that the most of the centers which are connected right now understand English language. That's why I am continuing in English. ईटानगर ऐसा है कि लाइक मोस्ट जितने भी सेंटर है ना, वो अभी मोस्ट ऑफ द स्टूडेंट्स आर इंग्लिश स्पीकिंग, तो वो अगर मैं हिंदी में भी बोलूंगा तो बहुत सारे स्टूडेंट को समझ में नहीं आएगा. दैट्स व्हाई मैं इंग्लिश में कंटिन्यू कर रहा हूँ. अच्छा, शिलोंग सेंटर, you also want to be in Hindi. Okay, one question I want to ask from all of you, since we are Hindi speaking nation. How many are comfortable in Hindi? -100. Yeah, I understand CC4. Okay, so we will continue in English because if one of the student cannot understand Hindi, then it's of no use. But we all can understand English, right? Shillong, please sit down. Please sit down. बैठ जाओ, बैठ जाओ. Okay, so let us find the relationship between the slant height, the radiuses, and the height. Now you can see how we can figure out this one. If this AB that indicates the height of the frustum, then you can draw this line also. That will also indicate the height of the frustum. So this will also be the height. Now what will be this distance? Let's say this is D and this point is C. So distance CD is nothing but the total BD minus BC, which is R1 minus R2. So this distance CD is R1 minus R2. Now in triangle ECD, that you can see the triangle, right angle triangle it is forming. So we can apply the Pythagoras theorem over here. So ED square, that is equal to EC square plus CD square. So ED square, that is L square, is equal to H square, and in place of CD we can write R1 minus R2 whole square. This is the relation number 1 between the L, H and R, slant height, height and the radius. हाँ Shillong, I will teach you separately in German and French. Don't worry. सोनू आती है आपको? You know German? That's great. Okay, so this is the first relationship between the slant height, the height and the radius. Now, yes CC4, yes, definitely. We'll also study in Japanese, Spanish, French, German, except English and Hindi, we'll study in every language. Okay, so is this clear till this formula? So note it down, this one. Second thing, this was the first point. Second thing, the curved surface area, the CSA, the curved surface area of the frustum. If you relate with the cone, the curved surface area of the cone was pi RL, that was the curved surface area of the cone. In case of this frustum, only difference is that the radius will be the sum of the radius. So pi R1 plus R2 into L. That will be the frustum of the curved surface area of the cone. Pi times R1 plus R2 into L. And talking about the TSA, so TSA will be pi times R1 plus R2 L plus the area of the top and area of the bottom, which is pi R1 square plus pi R2 square. So in the curved surface area, we can add both of them. So curved surface area is only the pi R1 plus R2 into L, and the total surface area, the curved surface area plus area of top and area of bottom. So area of top is the circle, so pi R1 square for that one and pi R2 square for the bottom circle. Yes, the trigonometry formula. Yes, Itanagar. And the third one, the derivations for these formulas are also there, but it is not in our syllabus, so we can just learn the formulas only. And the fourth one, which is the volume. So volume of the frustum, that is 1 by 3 pi h R1 square plus R2 square plus R1 times R2. That is the volume of the frustum. Only these four things are there, which you have to remember. Relationship between L, H and R. CSA, curved surface area, TSA, total surface area, and the last one is the volume. Okay, so let us start with the questions then. Okay, now this question. So the value of pi you have to use is 22 by 7. Like the first question says, a drinking glass is in the shape of a frustum of cone of height 14 centimeter. So height means h is given 14 centimeter. Diameters of its two circular ends are 4 centimeter and 2 centimeter. So it means the radius of both the ends are given. Find the capacity of the glass. Capacity of the glass basically means we have to figure out the volume. So formula for volume is 1 by 3 pi h R1 square plus R2 square plus R1 times R2. So the value of H is also given, value of R1, R2 both are given. We just have to substitute the value for all of them and then figure out the volume. That's right, CC4, correct answer. But the volume is not square, volume should be centimeter cube. Now it's right. Okay, so we'll take a quick break of 5 minutes, 10 minutes. So after the break, then we will continue with this one. So those who don't want to go for a break, you can solve these questions, and those who want a break, you can take a break. Okay, so answer for the first one, Senapati, that is not the right answer. Tamenglong, right answer. See, only you have to substitute the values. When you substitute the values, volume will be 1 by 3, height is 14, r1 square, so radius will be 2 and 1. So 2 square, which is 4, 1 square is 1, plus 2 into 1, which is 2. So 1 by 3 into 22 into 2, 7 times 2, that will be 14, and this is 7. So we just have to multiply this one, 44 into 7 by 3, that will be 308 by 3, which is 102 2 by 3. That is the volume for the frustum, first one. Getting it, Shillong? Shillong, Senapati. Now do the second one. Second question says slant height of a frustum of a cone is 4 centimeter and perimeters of circular ends. Perimeter means perimeter of the top and perimeter of the bottom. Circumference of the top circle and the bottom circle are this and this. Find the curved surface area of the frustum. That's right, Sisipur. Correct. You can try the third one. Yes, 48 centimeter square is the correct answer for second one. Tamenglong, Senapati, what are the answers? Shillong Center, where are you? Yes, Tamenglong, answer is right. So it says the slant height is 4. So L is given 4. Perimeters of the circular ends are this one and this one. So perimeter is 2 pi r. So 2 pi r1 is 18. 2 pi r2 is 6. We have to find the curved surface area of the frustum. Curved surface area of the frustum is given by pi r1 plus r2 into L. So we can, if we add both of them here, so pi r1 will be 9. So it will be 9 plus 8 into 4. So the curved surface area or 1 second. This is 6. So it will be 9 plus 3 into 4, which is 48 centimeters square. And try third one, all of you. It says that this is the cap and it is shaped like a frustum of the cone. Now this time the top of the cap is covered, but the bottom of the cap is uncovered or open. We have to figure out the area of material used for making it. So basically we have to figure out the total surface area of the cap, but the one of the circular faces will not be there. So curved surface area plus area of that covered face. Itanagar, are you talking about that second question, the pi? These are the dimension given for the cap: base area, top area, slant height. Using this one, you have to figure out the area of the material. So just figure out the curved surface area of the cap plus area of the top circle. $71. No CC4. The curved surface area for in the third case would be pi R1 plus R2 into L. This is the curved surface area plus area of the top, which is pi R1 square. This is the area of the material used in making the cap. Now in substitution, what you can do, you can take the things common. We can take pi as common. So it will be R1 plus R2 into L plus R1 square. So R1 plus R2, so radius is given 10 and 4. So this is 10 plus 4 into slant height, which is 15, plus R1 square. R1 means the small, radius on the closed side, on the upper base, which is 4. Only this thing we have to calculate. So it is 22 by 7. 10 plus 4 is 14, and 14 into 15 is 210 plus 16. So 22 by 7 into 226. Just calculate this thing, that will be the answer. Getting it, all of you, till question number 3? Any doubt? Yes, 710. That is correct answer, CC4. शिलोंग सेंटर क्या हो रहा है वहां पे? What are you doing? After this, try the fourth question. It's a very good question. The fourth one. Shillong, answer for this one is 710.28. Now try question number 4. It says a container opened from the top and made up of a metal sheet is in the shape of a frustum of a cone of height 16. This time the height is given. Whenever it is written height, by default it means the vertical one, h. Okay. And with radius of its lower and upper ends are 8 and 20 centimeter respectively. Find the cost of the milk which can completely fill the container at the rate of rupees 20 per liter. So we have to figure out what is the cost of the milk which will completely fill the container, and the rate of the milk is 20 rupees per liter. So first you have to figure out the volume of that cone, a frustum of cone. Sisipur, what is the answer you are getting for fourth one? And Tetso College, Tamenglong, what are your answers? Sisipur, the figure is somewhat correct, but I think you are having a problem in the decimal part. Tamenglong, your answer is right. Yes, Itanagar, the volume is right. Okay, now I am solving the fourth one. All of you please concentrate, Shillong Center. The question says that a container is like this. And we are given the height is 16. So this height is 16 given. And radius of lower and upper ends are 8 and 20 centimeter. So this radius is 8 and this radius is 20. So we have to figure out the cost of milk which can completely fill the container at the rate of 20 rupees per liter. So this is the cost of the milk, rupees 20 per liter. So we have to figure out first of all what is the volume of that tank in terms of liter, then multiply it by 20. So for the volume, we require, we can directly solve it for that one. So volume is 1 by 3 pi h r1 square plus r2 square plus r1 r2. So height is given, both the radius are given, and it says that we have to use the pi as 3.14, height is 16, r1 square, so r1 is let's say 20, so 20 square is 400 plus 64 and 20 into 8, that is 160. So if you are going to add this one, that will become 624. Now if you are going to solve this one, that will be going to be 10449.92 centimeter. Since all the values are in centimeter, so it will be centimeter cube. Now we have to convert this into liters. So the relationship between liter and centimeter is that 1000 centimeter cube is equal to 1 liter. So 1000 centimeter cube is equal to 1 liter. So in order to convert that into liter, we have to divide it by 1000. So that will be 10.44992 liter. Or we can also say, if we round it off, it will be 10.45 liters. So now the cost is, for 1 liter of milk, cost is rupees 20. So cost of milk is 10.45 into 20. That is going to be approximately 209 rupees. Getting it, all of you? Any doubt in this one? The second part of the question is also the same thing. It says, find the cost of metal sheet to make the container if the cost of sheet is rupee 8 per 100 centimeter square. So cost of the sheet means you have to figure out the area, or you can say what is the amount of material used in making that one. Only thing you have to take care in mind is that the container is open from the top. So it means we will take into consideration the curved surface area and only the bottom area. Sisipur, Shillong, Senapati, any doubt in this question? So this frustum is it's little bit of, you can say, calculation is required, but the questions are straightforward. Now there is one good question. Try this question, all of you. It says, yes, Itanagar, that is also the right. Yes, Itanagar, that is right. Cylindrical cans are there. Of radius 7 centimeter and height 30 centimeter. Dimension of box is length is 76, breadth is 46, and height is 45 centimeter. Find maximum number of cans that can be fit in the box. So there are the cylindrical cans in the shape of a cylinder. The radius and height for that cylindrical cans are given. There is a box. Length, breadth and height for that box are given. We have to figure out what is the maximum number of cans that can be fit in the box. How many maximum can you can fit in the box? Figure out the maximum number of cans that can be fit. And here the important thing you will understand that we are not deforming the cans Uh, no. Here the main thing is that we are not deforming, we are not melting the cans. The can are also solid, the box is also solid. So if you are thinking like dividing the volume of the box by the volume of one can, that will give you the total number of cans. That is wrong, because that formula works when we are melting the balls to make another shape. Right now both are solid, so you have to visualize this thing to figure out what is the maximum number of cans that can be fitted. Thirty-four cc4. No. How you are calculating cc4? Are you dividing the volume of the box by volume of can? शिलोंग, सोनू, समझ में आ रहा है? Uh, 749 is also not the correct answer. Okay, see, let us solve this one. It's a conceptual based question, not to be solved using the formulas. So first of all, let us draw the shape of the box. So formula is not used. This is just based on the mental practice, like how you can visualize the thing. Since we are not dividing the volume of the box by the volume of the can, so using formula will not help over here. See, understand in this way. This is the box. Let us draw the box. It is like this. Right, and this part, the length is 76, this is 46, and the height is 45. Now each cylindrical can is of height 30, and the radius is 7, so diameter is 14. That is given. Now we have to think what is the maximum number we can put. If you are putting that cylinder vertically in this box, So if you put vertically, the height of the box is 45 and the height of the cylinder is 30. So we can put vertically. If you put vertically over here, like one of the can, like this in one end of the box, second can will be like this. So how many can we can put along the length? Total length is 76 and the width of the one of the can is 14. So what is the multiple of 14? Just less than 76. It is 70. So it means 5 can we can put. So if you place 5 can like this, 1, 2, 3, then 4, and then 5. Some of the space will be left, that is only 6 centimeter space will be left, but in that space we can't put any other can. So along the length we can put 6. Now how many 5 we can put? Along the breadth, how many cans we can put just after this layer? So you can see that the breadth is 46 and the width of one can is 14. So how many can we can place along the length? It will be only 3 because multiple of 14 just less than 46 is 42. So 3 we can put. So it will be 3 over here, 1, 2 and 3. So vertically if we see 5 in the front row and 5, 5 and 5. So total on the bottom it is 5 into 3, 15 cans can be placed. Right? 5 in the front row and then 3 layers after that. So total 15. Now you can see that when we have, if you see the front like this, the front view of the box, if you see, it will look like this. 1 can, 2 can, 3 can, 4 can and 5 cans. These are the 5 cans. From the front side you can see. The total height of the box was 45 and the height of the can is 30. So still we have 15 centimeter is left, right? That 15 centimeter on the top is left in the box. Now in that one we can put the can in a horizontal way like this. We can put. So we can put the can like this. In a horizontal way we can put the can like this. Because the diameter of that one is 14 but the height of the box remaining is 15. So that one of the can horizontally can be placed. Now along the length how many can we can place? Since the total length is 76 and height of the one can is 30, so we can put 2 can. This will be of 30 and another can will be like this. 2 can we can put. Are you getting it? So remaining part is left but we can't use that space. Now 2 can along the length. Again along the behind those 2 can, how many cans we can put? You know, again the width is 46 and the diameter of the can is 14. So we can place only 3 cans because 14 times 3 is 42. So after this one we can place 3 can also. So these can will be 2 in one row and there is 3 rows are there, which is 6. So 15 from here and 6 from here. So 15 plus 6, which is maximum number of cans we can put is 21. Getting it all of you? जैसे अगर आप यहां देखो, कुछ कैन तो हमने ऐसे वर्टिकली प्लेस कर दी, लाइक दिस, वर्टिकली वी हैव प्लेस्ड, एंड जो टॉप में इसकी रिमेनिंग पोजीशन रहेगी उस पर हमने हॉरिजॉन्टली ऐसे प्लेस कर दी कैन्स को. So that is the meaning, like 15 vertically and 6 horizontally. All of you are getting it? ईटानगर इट सेज दैट देयर आर सिलेंड्रिकल कैन, एक कैन का जो रेडियस है 7 है एंड हाइट इज 30 और बॉक्स की डायमेंशन दे रखी है। आपको ये बताना है कि उस बॉक्स के अंदर मैक्सिमम कितने कैन फिल कर सकते हैं। तो आपको ये देखना है कि इसमें वॉल्यूम को हम डिवाइड नहीं करेंगे बिकॉज दोनों सॉलिड ऑब्जेक्ट है। सो इस तरह से हम इसे प्लेस कर सकते हैं कि लाइक पहले हम वर्टिकल कैन प्लेस करेंगे। सो अलोंग द लेंथ हम कितनी कैन प्लेस कर सकते हैं? Length of the box is 76 and if this is 76 and width of one of the can is 14, so we can place maximum 5 can in a row because 14 times 5 is 70 and width of the box is 46. So how many cans we can place along the breadth? 14 times 3 which is 42 because 4 we cannot place, it will exceed 46. So in the front row we can place 5 and there are exactly 3 rows are there. So total 15 cans. Now on the top of the box there will be some place left because the height of the box is 45, height of the can is 30. So 15 centimeter is left. In that 15 centimeter we can place the can horizontally because the diameter of the can is 14. So one of the can be placed like this, like you can see the pink one. Another we can also place adjacent to that one because the complete length is 76 and length of 2 can will be 60 and again we can place 3 more rows after that. So that will be 6 more can. So 15 plus 6, total of 21 can we can place. All of you are getting it? The meaning is without you. Sisipur, the meaning is without you. Got it? Okay, so that's all in this chapter. This chapter is finished now, the surface area and volume. If you have any doubt, you can ask me in the next class. Otherwise, we are going to start the chapter geometry in the next class. That is the circle. The geometrical part of the circle that we are going to start in the next class. Okay then, thank you. We'll meet in the next class then.